Let's talk about doing calculations with units. And there are different rules involving adding and subtracting versus multiplying and dividing. When adding and subtracting units, the units have to be the same. We can only add like quantities, apples to apples, oranges to oranges. We can't add apples and oranges. So the first one, 8 centimeters plus 7 centimeters, we do the numbers. 8 plus 7 is 15, and the units wind up being 6 centimeters. The next problem, 5 centimeters plus 4 millimeters, can't do at the moment because the units are not the same. But we could probably do a conversion and get them to where they are the same. But let's wait to the end of what we're doing till we do that. So let's first talk about multiplying and dividing with units. Here the units don't have to be the same. Oftentimes they're not. What we'll do is do the numbers first, do that arithmetic, then algebraically cancel out whatever units that you can, or combine whatever units. So the first one, 8 centimeters times 4 centimeters times 3 centimeters. If we do that on our calculator, we come up with the number 96. But we can't stop there. We've got to include the units. So centimeters times centimeters times centimeters gives us centimeters cubed. So the correct answer is 96 centimeters cubed. The next problem, 9 centimeters times 4 centimeters divided by 6 centimeters. Numerically, the answer is 6. If we do the units in the numerator, centimeters times centimeters is centimeters squared. We've got centimeters in the denominator. But we can further simplify this, cancel out those centimeters, or at least subtract the exponents. 2 minus 1 is 1, and so our answer simply becomes 6 centimeters. The next one, 8 centimeters divided by 4 seconds. 8 divided by 4 is 2. There are no units that cancel. So our answer winds up being 2 centimeters per second. The next one, 5 kilograms squared divided by 6 kilograms to the fourth. 5 divided by 6 is 0.83. We'll retain the units of kilograms because they don't exactly cancel. And since we have exponents, we're doing a division, we want to subtract those exponents. 2 minus 4 is negative 2, so the correct answer is 0.83 kilograms to the minus 2. The next problem, 6.2 times 10 to the third meters to the fourth, divided by 8.1 times 10 to the second meters cubed. First, do the numbers. So 6.2 times 10 to the third, divided by 8.1 times 10 to the second, gives us 7.65. The meters don't exactly cancel, so we carry forward meters. We're doing a division, so we'll subtract the exponents. 4 minus 3, which is 1, so our answer winds up being 7.65 meters. The next problem, 6 kilograms times 9.8 meters per second squared, or meters divided by second squared, gives us 5.9 kilograms times meters divided by second squared. Nothing cancels in terms of units here, but it's kilograms times meters divided by second squared. Next problem gets a little bit more complicated. 2.2 moles times 0.0821 liters times atmospheres times moles to the minus 1 times kelvins to the minus 1 times 298 Kelvin divided by 1.6 atmospheres. First we do the numbers. 2.2 times 0.0821 times 298 divided by 1.6, and we will get 3.4 times 10 to the 1 on our calculator, or 34. Then we do our units. Moles times the reciprocal of moles cancels. Kelvin times the reciprocal of Kelvin, all those are in the numerator, so Kelvins cancel. Then we got atmospheres in the numerator, atmospheres in the denominator. What we're left with is units of liters. So 3.4 times 10 to the first liters, or 34 liters. This is an example of the type of problem we'll be working when we use gas laws. Now let's go back to the problem we left undone from up above. 5 centimeters plus 4 millimeters. This turns out to be a problem where we can wind up actually solving this problem. We need to do a conversion of millimeters to centimeters or centimeters to millimeters. Let's convert millimeters to centimeters. And so to do that, I want to do that stepwise, going from millimeters to meters, and then to centimeters. So 4 millimeters. I want my conversion factor be millimeters in the denominator. That gives me meters in the numerator. That conversion factor is an identity. The numerator has to equal the denominator. And so milli means 10 to the minus third. 10 to the minus third. So 10 to the minus 3 meters over millimeters. That way millimeters cancels. Now I want to cancel meters and wind up with centimeters. And a centi means 10 to the minus 2. So 10 to the minus 2 goes with meters in the denominator. Meters cancels, and I wind up with centimeters. And that winds up being 0.4 centimeters. Now I can add that to my 5 centimeters, since the units are alike, and I get 5.4 centimeters. So that's an example where I didn't have units exactly the same, but I can do a conversion to get them to where they are the same. Now if we'd done something like meters plus kilograms, we would have been stymied, because there we're doing length and mass. Here all the numbers were length, so we could do a conversion to get them to where they are the same.